I very much like this telescope and this setup, and I'd like to tell you why. My name is Chris, and welcome to my basement. For 2 years now, I've pushed this telescope as far as I think pretty much anyone when it comes to astrophotography. And with that much experience, I think I'm finally ready to give my review. So let me give you a brief overview of the telescope as it comes out of the box, and then I'll dive into how well it holds up for astroimaging. So this is the Celestron NexStar 6SE. The NexStar line comes with these NexStar mounts, which are computerized mounts with go-to functionality. They work normally in alt-azimuth mode. That means that they sit flat and they track the sky in the zigzag pattern. The go-to functionality allows you, once you've aligned your scope, to punch in whatever object you want to look at, or the coordinates of any objects as well, and the scope will go to that object and keep it within your field of view as you, in theory, observe through the eyepiece. That kind of setup is not really conducive to imaging, and that's where Celestron comes in, making this Wedge available, which turns an Alt-AZ mount into an equatorial mount. In equatorial mode, rather than going through the zigzag pattern across the sky, the mount is able to track in right ascension using a single motor, which makes for a much smoother experience and allows you to take longer exposure imaging. Now, the basic scope itself is this optical tube assembly, or OTA here, the classic tube, this NexStar mount, and the tripod. All those three pieces ship together, and when you get them, you get this 6-inch aperture OTA. It is 1,500 millimeters in focal length, making it an f10 scope, which isn't particularly fast. It comes with a manual focus knob, which I have replaced with a motorized focuser, a 1 1/4 inch visual back, that is what you connect your other visual components to, a star diagonal, which takes the image and redirects it so that you have a right angle that you can put your eyepiece onto, and a 25 millimeter eyepiece, also 1 1/4 inch diameter. The tube is mounted onto the NexStar mount using a Vixen Dovetail, and the mount itself has these two clamps that come together using this bolt underneath that you tighten to secure the OTA. The OTA has a finder scope, or what is called a finder scope, but is in fact a little red dot finder. That's a little reticle with a projected red dot that you line up with what object you're trying to see in the sky, and then you're able to see the same object through the eyepiece. The NexStar mount comes with a battery compartment for 8 AA batteries. I'll be honest with you, those don't last very long and you can't really depend on them. I use them if I need to shift the mount around when I'm inside and I need to reorient something, but normally if I'm out observing or doing some astrophotography, I'll be running this mount off of an external AC adapter, which does not come with the telescope, and to me that is an oversight. The NexStar mount has two ports, a guide port if you're guiding with the telescope directly. If you have a guide scope like I do, you can take the guide camera, output it to the guide port to enable that guide functionality. There's also an aux port where you can connect accessories. Now I have my focus motor running through the aux port, and then I'm using my laptop to actually drive the telescope through a USB connection that connects to the bottom of the hand controller. The hand controller and the computer inside has a catalog of 40,000 items that you can go to with the telescope. And finally, the OTA comes with this little plastic dust cap. Now, the Celestron NexStar 6SE is what is known as a Schmidt-Cassegrain telescope, or an SCT. What makes an SCT is that it is a reflector, meaning it has a primary mirror in the back here. Light comes in through the aperture, bounces off of the primary mirror, bounces off of a secondary mirror that's right at the front of the scope, and then out the back and onto your visual or imaging components. The SCT also has a lens at the front, which is not so much a lens but a corrective plate, which serves to correct some optical aberrations that occur with reflectors. The optical tube assembly weighs 8 pounds. The NexStar mount weighs 11 pounds, so that's a total of 19 pounds between the both of these. And the tripod weighs 9 pounds. That's 28 pounds total. The wedge comes in at a whopping 15 pounds of cast metal, for a total of 43 pounds if you connect all of these pieces together, plus whatever additional components you might have, such as your camera, your piggyback mount, your guide scope, and additional accessories. So fully kitted out for astrophotography, you're looking at a combined weight somewhere in the range of 50 pounds. At 50 pounds, the rig is awkward to lift, given that all of the mass is distributed, making the scope unwieldy to try to pick up. When transporting the scope, what I typically do is I disconnect the NexStar mount and the OTA from the wedge and the base. Because I'm observing from the same location in my backyard all the time, rather than using the tripod, I've made a pier. Because I'm using this pier and I don't have very far to go, what I typically do is just disconnect this wedge from the tripod and carry the wedge together with the mount and the OTA. Now, if that doesn't work for you, then I suggest keeping the mount and the OTA together and carrying the wedge separately. This is because it does take a bit of finessing to get the balancing just right. And for that reason, I don't like to disconnect the OTA from the NexStar mount unless I absolutely have to. There are many reviews of this scope when it comes to visual observing, so I'm not going to spend too much time on that. Suffice it to say that my experience visually was very satisfying. I enjoyed it. I just couldn't see very much from where I was. It's hard to describe that visual observing experience, short of saying that some of the early attempts that I did at astrophotography was actually taking some video using the video mode on my Nikon. So here's a couple of examples of what your experience with an eyepiece would be like as the video kind of matches what I remember seeing. So you can see some visuals of the moon. In this case, this was shot with an iPhone through the eyepiece with a Barlow. You can see a couple of short videos of Saturn and Jupiter. So let's talk about astrophotography. To connect your DSLR to a telescope like this one, you need two components. You need a T-adapter and a T-ring. The T-adapter is a tube that connects to the visual back of your telescope and then onwards to the camera. Connecting to the T-adapter is what's known as a T-ring. The T-ring has a connector that's specific to your camera brand and model that allows you to connect the T-ring in place of a regular lens, and it provides for the right back focus distance in order to allow your camera sensor to come into focus from the visual back. Now, in that most basic setup, if you're running the scope without a wedge, without guiding, you're going to be able to do kind of what I was showing earlier with the two videos, or the three videos of the planets and of the moon. You really won't be able to do much astrophotography. Here's a couple of examples of images that I tried to take with longer exposures with my Nikon camera with this telescope in Alt-AZ mode. As you can see from those, they didn't quite work out. Right? The scope wasn't stable enough. It wasn't tracking in the correct direction. It was doing a zigzag pattern. So if you really want to do astrophotography with this telescope, what you need is a wedge to turn this Alt-AZ mount into an equatorial mount. Now, if you're new to astrophotography and astronomy, then you might be surprised that many professional telescopes actually use wedges. Now, while this is not a professional telescope, the wedge itself is solid. And the combination of this little NexStar mount with this solid wedge actually makes for a not bad platform for imaging. My interest in astrophotography was to enable me to view those objects in the sky that I wanted to see visually but couldn't from my backyard because of light pollution. This telescope, with this wedge and this astrophotography setup, has enabled me to pursue this hobby. So how does this scope with a wedge do with astrophotography? Well, it's capable of this. Here are a handful of images that I've taken and posted in prior videos through this telescope. I'm not going to be winning any imaging contests, but I can't stress enough that that's not my interest. Which brings me back to this review. If you have this telescope, and for that matter, probably any 6-inch SCT, or maybe an 8-inch on a more robust mount, in my opinion, you can take some satisfying images. So let's start with the practical, the field of view. At f10 and 1500 millimeters, what you can image with this telescope would be in the realm of galaxies. Most galaxies. You wouldn't be able to fit Andromeda or much of Triangulum, but you can see but many other galaxies certainly fit into that field of view. You can see globular clusters, you can see planetary nebulas, and you can see some of the smaller reflection and emission nebulas. In order to image those with a DSLR, and I think this would be true no matter what the telescope is, you would need a lot of exposure time, which is harder to do without guiding, but not impossible, especially if you have your polar alignment down to a science. Now, my recommendation here is to reduce the focal length of the telescope by using a focal reducer. Celestron sells a focal reducer for this telescope, which takes the telescope from an f10 to an f6.3, reducing the focal length from 1500 millimeters to just under 1000. The Celestron focal reducer also does some flattening of the image, which means it will reduce some of the stretching of stars around the edges of your image. Now, let me point out here that from my experience, the flattening isn't as good as it could be. And here's some examples of what the field of view looks like, both at 1500 millimeters and then with the focal reducer. So you can see with the focal reducer, there is a broader field of view, and the stars aren't quite as stretched in the corners, but there's still some stretching. There is spherical aberration that happens, and a little bit of chromatic aberration around the edges of this telescope. With the f6.3 focal reducer, the scope also becomes much faster, down from an f10. That means it gathers more light faster. As a result, your images require less time, or more importantly, you get more data in your images with the same amount of time. I'm not going to say too much about the optics because, again, many people have done reviews of these telescopes, and this was for a long time Celestron's flagship product. The optics are going to be pretty good. I think what's more relevant when it comes to imaging is talking about the scope's ability to track targets. So one of the things that I've learned over the last couple of years is that no mount is perfect, and every mount is going to suffer from some sort of periodic error. What that means is, especially if your mount uses gears like this one does, you're going to have some imperfections in those gears. Even tiny, minute imperfections are going to cause a periodic wobble in your field of view as you're tracking. Uncorrected, that wobble and the frequency of that wobble is going to limit how long of an exposure of an image you can take. I tested this scope, and I found that my periodic wobble happens between 30 and 40 seconds. Which means, at best, I can take 30-second exposures before I get trailing induced by this imperfection. I can correct for that imperfection using guiding, because guiding will get in front of that, and as soon as things start to shift, the guide scope and the guiding software will send corrections to the mount so that the mount stays on target, thus giving me much longer exposure times. I typically shoot at 3-minute exposures, and I'm mostly limited by light pollution, because any more than 3 minutes and the light pollution is going to overwhelm my images. So since this is a review of the telescope for imaging, we have to talk about the wedge. If you'd like to know how to use a wedge or how a wedge works for astrophotography, there's resources out there. I put out my own video about wedges, which you're welcome to have a look at. But as a very brief summary, the wedge plate that the mount sits on should be aligned with the celestial equator. And the axis that goes through the center of the scope should be lined up with the North Pole, or the axis of rotation of the Earth. What this does is it allows the scope to track in the plane of the celestial equator, counteracting the spin of the Earth. And that's what allows you to stay on target and take long exposure images. When you see astrophotographers getting set up with their German equatorial mounts or harmonic mounts, first thing they'll do is polar align their mount. Polar aligning one of those types of mounts usually involves setting up the mount so that it's more or less oriented towards the north, looking through a telescope that is called a polar scope that runs right through the axis of the mount and has a little diagram showing the positions, or the relative positions of Polaris. And the idea there is that any given night, at whatever time, you should be able to match up the position of Polaris, using, say, an app on your phone, with what you're seeing through the polar scope. And when you've lined up where Polaris lies, you know that your telescope is more or less polar aligned. And that polar alignment pretty much ensures that your mount is more or less lined up with the axis of the Earth. As you can see, there is no polar scope on this mount or wedge. In fact, there's not too many right angles of any sorts to mount one onto. So what do? Once again, there's a whole wealth of advice offered on the internet. I myself have posted a couple of videos on how to polar align your mount, both using the hand controller as well as aligning using a laptop with CPWI software. But the rough idea is basically this. You want to get your mount on your tripod so that the back leg of the tripod points towards true north. And then you want to set your declination using these tick marks here on the wedge to your latitude. By aligning the back leg to north, you're making sure that the scope faces south. By setting the wedge to your latitude, you're more or less setting the wedge plate to align with the celestial equator. Now that's a very rough alignment, and you're going to have to fine-tune that. And there's techniques for doing that as well. And one of my favorites is something called drift alignment. Drift alignment, in essence, is seeing which way the stars in your field of view are trailing, because by determining which way they're trailing, you can infer which direction you need to adjust your mount to in order to dial into a proper polar alignment. All right, let's say that your scope and your mount is properly polar aligned. What should you expect then? My experience with this setup is that it tracks pretty well. As I've mentioned, there is that periodic error that crops up, that wobble that limits your exposure times. But other than that periodic wobble, I found that the scope stays on target, meaning the object that you're imaging stays in the center of your field of view for quite a long time. I haven't actually measured how long it would take for an object to move out of the center of the field of view, but I did do an entire video where I imaged a globular cluster using 15-second and 30-second exposures over the course of several hours. So, without guiding, you can absolutely take astro images with this setup. As a matter of fact, all of the images that I took in my first year of astrophotography were taken with an unmodified Nikon and this scope on a homemade wedge. So what are the components that are really important for astro imaging? Well, it's your optics, the quality of your mount and its ability to track objects in equatorial mode, the ability of your mount to use guiding in order to take long exposures, and finally the quality of your camera. Now, I started using a DSLR. A DSLR has filters that prevent frequencies of light beyond the lower and upper threshold, pretty much cutting off a lot of the ultraviolet and infrared ranges. A lot of the interesting signal that you get from objects in space happen to reside in those frequency ranges that a DSLR by default cuts out. That's where a lot of people modify their DSLRs. Now, I did not want to do that because I didn't want to ruin my DSLR for other imaging. Last year, I upgraded my camera from the unmodified DSLR to an actual astrophotography camera. The difference in image quality that I experienced going from the unmodified Nikon to the Astro camera was tremendous. Now, here's a few samples of the types of images that you can expect with such a camera through this telescope. Let's go over some of the obvious cons to this telescope. The most obvious and glaring issue is that there is not much space in the back of this scope. You see, because Celestron made this setup primarily for visual observing, they didn't leave very much space behind the telescope to fit a camera. Now, it just so happens that if you use the Celestron f6.3 focal reducer, you're going to need a certain amount of additional space called back focus in order for your camera sensor to be in a position that it can focus. And that distance is roughly 105 millimeters, which means that you're going to have a field flattener, which is yay thick, followed by 105 millimeter tubing, followed by your Astro camera on the back of this telescope, which is exactly what I have here. Had this telescope been sitting on the Dovetail that it shipped with, that camera would be hitting the wedge, and that's a problem. It's a problem that could have been fixed had Celestron put a longer arm on this mount. But they didn't, and now we're left with three options. Option one, you can set up your telescope to limit the altitude. The upside is that you won't damage your camera. The downside is that you won't be able to tilt your telescope past a certain angle, and you'll be missing access to a whole range of the sky. Your second option, and I've seen this done before, is to use a diagonal, meaning you connect your visual back to your diagonal and then your camera to that diagonal. The problem with that approach is that you do lose some quality of light passing through the prism, and also that your image is now reflected, which is more of a nuisance. But at the very least, you'll be able to tilt the telescope and have access to the entire sky. Your third option is doing what I've done here. I added an extension dovetail, which allowed me to push the optical tube assembly forward enough to be able to fit my whole imaging train. Unfortunately, that shifted my center of gravity so far forward that I needed to compensate with additional weights, which means that this setup is actually about 5 pounds over the registered capacity of the Celestron NexStar mount. In theory, that's going to reduce the life expectancy of this mount as it puts additional pressure on the gears. In practice, what it means is that I have to be very careful to make sure that the scope is very well balanced. As with this much weight, if the scope is not balanced, my guiding is going to start to pull in the unbalanced direction. And that right there, I think, is the biggest downside. All right, speaking of tracking accuracy, I also want to mention that when it comes to astrophotography, one of the things that we're concerned about is guiding error. What that means is, how much error in arc seconds does the guide scope have to help the mount compensate for in order to keep on target? Very good mounts have very small error, sometimes less than half an arc second. Cheap mounts are going to have a lot of error. Now, that error does depend on things such as weather conditions, availability of good guide stars, wind, and most importantly, the quality of the mount. Now, this entire telescope costs as much as an entry-level mount. So what kind of guiding error can you expect? Once again, I can only draw on my own experience, but I typically get error between 0.7 arc seconds and about 1.8, which marries pretty well with the needs of this telescope running with a focal reducer. Also, that is the error range that you should expect from a lower to mid-tier mount, which, considering the price point of this telescope and mount together, I think is pretty good. Alright, let me quickly round out this review with a couple of things I like and I don't like. Starting off with, I really don't like the hand controller. I don't find the menu system intuitive at all. There is a whole setup sequence you have to go through in order to set up your time zone, your location, your daylight savings time, and then to orient the scope in order to align it, at least for visual in Alt-AZ mode, to 2 or 3 stars. I just found that whole process somewhat frustrating. I suppose if you're using the telescope every day and you know the menu system like the back of your hand, that'll be a different story. What I do like is the interface the mount has to a laptop. So Celestron has a software that, if I'm not mistaken, was partnered with PlaneWave called Celestron PlaneWave Instruments, or CPWI. CPWI is control software that allows you to connect this mount to a laptop or a PC computer using a USB cable, thus allowing you to control the entire mount with a point-and-click interface that lets you work with a map of the night sky. CPWI comes with a ton of objects, more than the hand controller alone. If you're connected to the internet, then you have access to the SAMBADS database. You can put in your own coordinates. You have a GUI interface for slewing around with the telescope. You have a GUI interface for the focus motor. And what is to me one of the funnest features, you can connect a game controller. So I personally use an Xbox controller to slew around with the telescope. Now there is a downside here, which is that if you're using CPWI, the hand controller can no longer be used to slew the scope. So the game controller is a nice add-on to replace that. Plus, if you're going to be contorting yourself underneath the telescope trying to look through the red dot finder to align on a star, it's so much easier to have a controller that you can use right there and then rather than to go back and forth between your laptop and the telescope. The bolt that tightens the vise from the NexStar mount onto the Vixen Dovetail is located on the underside, and you do need to crank this with some torque, which can be difficult if the bolt seizes up, say in the cold, and to get around that, I usually carry a rubber wrench. One other issue that I find with this mount is that the hand controller is not secured particularly well. So what I've done is I've used a piece of Velcro to keep the hand controller from falling out. This isn't a problem when the mount is in Alt-AZ mode, but sitting on the wedge, the mount can get into positions where the hand controller can now easily fall out. Another issue with the hand controller I found is that it can overheat in direct sunlight. Meanwhile, in the winter, the readout on the hand controller becomes very sluggish, and the menus take a long time to change. And I've had situations where I've been doing some solar astrophotography, and the hand controller and the mount have stopped responding. At one point, this happened while the mount was moving, causing the mount to slew without any control. I had to race down to stop the mount before it ripped out the cables. Which brings me to another issue, which is that you have to remember to set the cord wrap setting in CPWI, lest the mount try to turn around on itself. This has happened to me on a number of occasions where I've forgotten to set the setting, and as a result, I'm on my third power adapter. One other tip I can give you is that these little rubber tips that go onto the bottom of the tripod do wear out. They are very flimsy, and when they wear through, the metal can protrude out the bottom. I have yet to find replacement tips for these, so what I found I can use is these walking stick or hiking pole tips. You can cut these down to size, and then they do fit on the ends of the tripod. One other thing that I found is that this dust cap seems to have shrunk somehow over the years. So it no longer tightly fits onto the OTA front. If the OTA leans forward too much, this dust cap has fallen off and fallen onto the ground. I find that the mounting bolts that are on top of the scope on the left-hand side don't have enough clearance to mount any accessories when you've pushed the OTA forward on its dovetail. I've gotten around this purely by accident because I've had to extend my dovetail. The dovetail that I purchased wasn't rounded to match the curvature of the OTA. So rather than to try to mount a flat dovetail onto a curved OTA, instead I mounted the new dovetail on top of the old one. This has given me another ½ inch or so of clearance, which works quite well to allow me to move the red dot finder from the right-hand side to the left-hand side. The red dot finder is incredibly flimsy. Not only is it flimsy, but the red dot finder does not have an auto shut-off. And if you're like me, and probably most people, you're going to forget to turn that damn thing off and wear out your battery. So personally, I keep a stack of 2032 batteries lying around just in case. And I should warn you that I've had one red dot finder that's burned out already because of how long I've left it on. An awesome thing about having a go-to mount sitting on a wedge is that I don't have to worry about meridian flips. Unlike some other equatorial mounts, there's no concern that the scope is going to tip over or hit the tripod as it tracks or slews around. And from a standpoint of remote operation, that means I don't have to worry about where the objects are in the sky that I'm asking the scope to go to. Nor do I have to worry about stopping my imaging session as the scope crosses the meridian, or worry about adjusting my camera later and recentering and reframing my objects. Which means once I get the scope going with an imaging plan, I can go to sleep and check back the next morning. So in summary, the Celestron NexStar 6SE is definitely capable of astro imaging. Celestron knows this, which is why they sell wedges and camera adapters. The tracking ability of the NexStar mount with a wedge is surprisingly good for the price point. The optics of the scope are what I suppose you would expect from a decent reflector, and with a focal reducer, you get a slightly faster scope and a better field of view. I love that this scope actually comes with a little DSLR piggyback adapter that you can use to mount your DSLR and run at the same time as your telescope to take some wider field imaging. I've used it to get some pretty cool time-lapse photos, as well as photos of constellations that put my astrophotos into a nice framed perspective. I like the idea that a lot of the astrophotography components are interchangeable and can be used on a different telescope should I choose to do that in the future. I also love the idea that if I ever needed to, I could take the scope without a wedge, put it back into visual mode, and enjoy some astronomy in a darker sky location. So to me, and again for the price, this is a very versatile little rig. And in terms of does it do what I needed it to do, absolutely yes. It's brought the whole world of astronomy to me in my backyard in a way that I wouldn't have been able to experience otherwise. I hope you found this review helpful. Thank you for watching, and clear skies. And the red dot finder has dewed over, which means, and all I can see through it is the bloody red dot and nothing else.